Welcome back to Cyber in Practice. I'm Lewis Knox, and in today's episodes, we're looking at Zero Trust Continuous Verification. We'll explore how modern security environments continuously evaluate access conditions before granting or maintaining access. So, what exactly is Zero Trust? Zero Trust is a cybersecurity model that assumes no user device or system should be trusted automatically. Instead of granting trust by default, access decisions are continuously evaluated using identity, device health, and contextual information. That's where the idea of never trust, always verify comes from. But continuous verification is what really makes zero trust work in practice. In a zero trust environment, security conditions are continuously evaluated before access is granted or maintained. That can include device compliance checks, identity verification, and context aware access decisions. If conditions change, access could be revoked immediately. So, how are those access decisions actually enforced? Policy engines evaluate multiple security conditions to determine whether access should be allowed or denied. This creates dynamic access decisions based on real-time security conditions instead of static trust. That allows organizations to enforce risk-based authorization and continuous policy evaluation. Now let's look at what this demonstration is going to simulate. In this demonstration, I'll simulate a zero-trust web application that evaluates device compliance, user identity, and access context. This application will dynamically allow or deny access depending on those conditions. Before we jump into the demo, here's a quick look at the tools being used. For this demonstration, I'll be working inside an isolated virtual lab environment using Kali Linux, Python Flash, Linux Terminal, and a web browser. I chose Python Flash because it provides a simple way to simulate real-time policy evaluation and dynamic access decisions. Before moving into the terminal, let's quickly look at the Zero Trust evaluation flow. In this simplified workflow, a user submits an identity request. That request is evaluated by the policy engine, which checks compliance, condition, and contextual information before making access decisions. Based on the results of those evaluations, access is either allowed or denied. Now let's move into the live demonstration to see how those access decisions change in real time. I already have the project workspace prepared, so I'm moving into the Zero Trust demonstration directory. Next, I'm activating the Python virtual environment used for the application. Now I'm starting a Flash application that will simulate continuous zero trust access evaluation. Here we can see the Zero Trust dashboard. Currently, the device is compliant, the user identity is authorized, and the access context is trusted. Because all required conditions are satisfied, access is allowed. To simulate changing security conditions, I'll use a second terminal to modify the values being evaluated by the policy engine. After refreshing the browser, access is immediately denied because the device no longer meets required compliance condition. Now I'll restore the device compliance status back to compliant. Now we'll refresh the browser and verify compliance status. Next, I'm changing the user identity status to unauthorized. Once the browser refreshes, access is denied again because identity verification has failed. I'll now restore the user identity status back to authorized and confirm the status has returned to normal. Now I'm changing access context from internal to external. After refreshing the browser, access is denied because the contextual access condition is no longer trusted. I'll now restore the trusted access context. I will refresh the browser to confirm compliance status. So to wrap everything up, this demonstration showed how zero trust environments rely on continuous verification instead of explicit trust. Access decisions are policy driven and based on factors like identity, device status, and access context. And if those conditions change, access can be revoked dynamically in real time.
Thank you for watching Cyber in Practice. If you enjoyed this demonstration, stay tuned for future Cyber in Practice episodes.